Good day, everyone. I am Mr. Ed Villamor, Teacher 2 from Tala High School, teaching General Chemistry 1 to my grade 11 students. The new normal in education demands a new approach in teaching our students. Discussions during online class are important, but what we do before and after our online class have a greater impact since our students will be answering their modules or homework tasks on their own. In this demo teaching video, I used Herman's whole brain thinking framework in delivering my lesson during our online class and gamified differentiated homework, an innovation of mine, which gamifies my students' homework task and provides differentiated activities to meet the needs of my diverse students. In my General Chemistry 1 class, I use Classcraft as a gamification platform where each student has their own avatar that they can personalize and modify by buying equipment using gold points or GP. They can choose from three different classes of characters: Guardian, Mage, and Healer. My students' outputs are made to look like quests that they have to accomplish to gain experience points or XP and GP. Experience points or XP can make their characters level up and open up new upgrades. They can upgrade their avatars from this to this, from this to this, and from this to this. I also use the boss battle feature as their formative test. Every correct answer can damage the boss, while an incorrect answer can reduce their character's HP or health point. If they manage to kill the boss, they get huge XP and GP as rewards. I modified my students' outputs into four types of homework tasks: the pre-learning homework to prepare my students for our online class, the checking of understanding homework that aims to check if they understood the lesson that was discussed, the practice homework that improves and develops students' mastery of the lesson, and the process homework that is similar to performance tasks to integrate the lesson to other disciplines. The practice homework is differentiated into easy, average, and difficult to cater the needs of my diverse students, but all of them are only required to answer the easy practice homework. Those who would want to answer the average and difficult practice homework are free to do so, but it will not be included in their grades. They only get extra XP and GP for their characters in Classcraft to motivate them to accomplish challenging tasks. These homework tasks have specific deadlines for submission, but those who submit early get extra XP and GP. For the actual online class, I used Herman's whole brain thinking framework in delivering my lesson. Unlike 7Es, Herman's WBT has only four parts: practical display, lecture, group activity, and individual activity. A few days before the online class, the students were given the pre-learning homework to prepare them for the lesson. So, good morning, class. Before we start our lesson, may I request someone to lead us in a prayer? May I ask Chloe Amparo? Chloe?
Let's close our eyes and feel the presence of the Lord. Father God, thank you for all the blessings that you have given us. Please forgive us with our sins. Come be with us today. Fill our hearts with joy, fill our minds with learning, and fill our classrooms with peace. We love you. In Jesus' name we pray. Amen.
Amen. To start off with our lesson, let us first review previous lessons that we will encounter in today's discussion. And we will do that by having a boss fight in Classcraft. So the boss that you are going to fight is named Tiny, and it is a crystal golem. If you manage to defeat Tiny, you get 1000 XP and 200 GP or gold points. So the team that will face off with Tiny will be Team 1. Are all the members of Team 1 here? I do hope so, because as you know, it will be difficult to fight a boss with some members missing. Okay, so let's start. So let's have Team 1. For the first fighter, let's have Danred Rafael. Kindly read the problem first. Danred?
Okay po. At the end of chemical reactions, what is the total mass of the reactants compared to the total mass of the products? 1. The product is doubled. 2. The mass is the same. 3. The product is half the mass of the reactants. 4. The mass changes depending on the reaction.
Your answer
2 po.
is
2. The mass
2.
is the
Okay, let's
same.
see if your answer is correct. Okay, so your answer is correct. Okay, for the next fighter, let's have Stephen John Manalansan.
What is a chemical reaction? Chemical equation. 1. A short way to show a chemical reaction using symbols. 2. A way to show a physical change using symbols. 3. A way to explain a chemical reaction using words. 4. A way to show a physical change using
Using
words.
words. Okay, your answer is
1. A short way to show a chemical reaction using symbols.
okay. Let's see if your answer is correct. Okay, very good. So a short way to show a chemical reaction using symbols. So that is a chemical equation. So that's minus 10 HP to our enemy, to our boss, Tiny. Next, let's have Haina Basolo.
The substances at the beginning of a chemical reaction are called the blank. 1. Product. 2. Chemical symbol. 3. Yield. 4. Reactants. My answer po is number 4. Reactants.
Number 4. Okay, let's see if your answer is correct. Okay, very good. So that is correct. So that's another minus 10 HP to our boss. Next, let's have Anthony Lumuntod.
Which of the following correctly balance in equation? Number T, sir. H2
Number,
plus Cl, I2 equals 2HCl po.
okay. So let's see if your answer is correct. Okay, very good. So H2 plus Cl2 gives 2HCl. So that's another minus 10 HP to our boss. And hopefully this is our last question until you finally defeat the boss. Okay, let's have RJ Alingod.
When balancing equations, a blank can be placed to the left of a formula of a substance to make the equations balance. 1. Charge. 2. Random number. 3. Subscript. Number 4. Coefficient. My answer, sir, is number 4. Coefficient.
Number 4, coefficient. Let's see if your answer is correct. Okay, very good, correct. So, congratulations, Team 1. You have finally defeated the boss for our today's boss fight. So for the next meeting, be ready. The other teams, be ready for the next boss fight. So review your previous lessons so that you can get the chance to earn additional XP and GP. Okay, let's start with our lesson. Chemistry is very similar with cooking. As one meme goes, chemistry is like cooking. Just don't lick the spoon. In today's lesson, we are going to discover how similar chemistry is with cooking. So by the way, let us recall the learning competencies that we are going to cover for this morning's discussion. So we are going to discuss how to construct mole or mass ratios for a reaction in order to calculate the amount of reactant needed or amount of product formed in terms of moles or mass. And this lesson is all about, again, stoichiometry. So what do you mean by stoichiometry? Kindly read the definition. Anyone from the class who would like to read? How do we
Sir,
define chemistry? Yes.
stoichiometry is the quantitative study or reactants and products in a chemical reaction.
Okay, so that is what we are going to explore for this morning. What is stoichiometry and how are the reactants and products are related to each other in terms of their quantity? And also, in today's lesson, we are going to discover how similar chemistry is with cooking. So there is an area in chemistry that is very similar with cooking, and that is stoichiometry. For us to better understand the connection between cooking and stoichiometry, let us have this analogy. I have here the ingredients that I use whenever I cook chicken adobo. So I have here 1 pound of chicken, 2 packs of peppercorns, 5 cloves garlic, 1 piece onion, 3 tablespoon vinegar, 4 tablespoons soy sauce, 2 cups of water, for me to cook 1 casserole of chicken adobo. So what if we alter the amount of one ingredient? How much of the other ingredients are we going to need? Or how much chicken adobo can you cook if you alter the quantity of one ingredient? So what if we have 4 pounds of chicken? How much chicken adobo can you cook? Any volunteer?
Sir, envoltorio po.
Okay, Embotorio, yes, your answer.
4 pounds of chicken can produce 4 casseroles of chicken adobo. Since the ratio between a pound of chicken and a casserole of chicken adobo is 1:1.
Okay, very good. If we look at the recipe, 1 pound of chicken can produce 1 casserole of chicken adobo. So that means the ratio between pounds of chicken and casserole of chicken adobo is 1:1. So since we have 4 pounds of chicken, we just have to multiply the amount of chicken adobo by 4. We have 4 pounds of chicken. So since the ratio is 1:1, therefore we just also have to multiply the other side of the ratio by 4. That's why we have 4 here as the answer. Okay, very good. Next, how about if we have 15 tablespoons of vinegar, then how much onions do we need? Any volunteer?
Po.
Yes?
Dwalong po.
Okay, Tuarong.
Since the ratio between the vinegar and onion is 3:1, all we have to do is to multiply both sides by 5, then we can get 5 onion as our final answer.
Okay, very good. So same explanation on how to get the quantity of onions. If we have 15 tablespoons of vinegar, we have to relate the quantity of vinegar, the ratio of vinegar with the quantity of onions. So since this is 3:1, and we have 15 tablespoons, to get 15, we have to multiply 3 by 5. So therefore, so again, you have to multiply 3 by 5 to get 15. Okay? So therefore, we also have to multiply the other side of the ratio by 5. That's why the answer is 5. Very good. Okay, let's have another one here. 4 cups of water. How many cloves of garlic are we going to need?
Ponciano, sir.
Okay, yes, Ponciano.
For 4 cups of water, we're gonna need 10 cloves of garlic because the ratio between cups of water and cloves of garlic is 2:5, so the answer is 10.
Okay, very good. So 10 cloves of garlic. Moving on, let's have 10 packs of peppercorns. Any volunteer?
Alingod, sir.
Yes, Alingod.
10 packs of peppercorn can produce 5 pounds of chicken. Since the ratio is 2:1, we just need to multiply by 5 both sides.
Okay, very good. So multiply both sides by 5. So we get 5 chicken casserole. Very good. Next, 3 pounds of chicken. How much tablespoon of soy sauce do we need? Any volunteer?
Sir Ubaldo po.
Yes, Ubaldo, destined.
In 3 pounds of chicken, we're gonna need 12 tablespoons of soy sauce since the ratio between the chicken and the tablespoon of soy sauce is 1:4 po.
Okay, so 1 pound of chicken is to 4 tablespoons of soy sauce. So it's 1:4. Since we have 3 pounds of chicken, multiply this by 3. Okay? Then we also multiply the other side by 3 to get 12. Very good. Okay, next. How about if we have 4 pieces of onions?
Asistores po, sir.
Yes, Asistores.
Okay, for every 4 pieces of onion, we're gonna need 20 cloves of garlic. Since the ratio of
20.
onions to garlic is 1:5, so that's 4 times 5, where 4 is the quantity of onion in the given and 5 is the ratio of garlic cloves in the outer recipe.
Okay, very good. Very well explained. So we will be needing 20 cloves of garlic if we have 4 pieces of onions. Okay, next. Second to the last. 12 cups of water.
Ponciano po.
Okay, Ponciano, yes.
For 12 cups of water, we're gonna need 18 tablespoons of vinegar since the ratio between cups of water and tablespoon of vinegar is 2:3 and then multiply it to 6. So the answer is 18.
Oh, okay, very good. So ratio between cups of water and vinegar is 2:3. Since we have 12 cups of water, then we have to multiply this by 6 to get 12. Then we multiply the other side by 6 also to get 18. Very good. Okay, and lastly,
Sir
10
Valentino.
tablespoons of soy sauce, yes?
10 tablespoons of soy sauce would be needed for 2.5 pounds of chicken since the ratio of a pound of chicken to soy sauce is 1:4.
Okay,
Both
so,
sides would be multiplied by 2.5.
okay, very good. Okay, so after that activity, let's try to answer these guide questions. So the first one is, what will happen to your chicken adobo if you were only given the ingredients but not the exact measurement? And explain your answer why. Any volunteer?
Amparo po, sir.
Yes, Amparo?
If we were only provided with the ingredients but not the exact measurements, we might not be able to cook perfect chicken adobo, or worse, create something inedible, thus proving that measurements are always necessary.
Okay, very good. So we might not get the desired taste that we want for our recipe if we do not have the exact measurements. So that's why whenever we are cooking, we must have certain measurements. Okay, these exact measurements, so that every time we cook a certain recipe, we always get the desired taste. Okay. Next, let's have number 2. How did you know how to compute for the amount of other ingredients in the activity?
Alingod, sir.
Yes, Alingod?
The activity provided data, and that data serves as the basis on how are we going to answer the activity. We just need to look at the relationship and ratio of the given ingredients to compute for the amount of ingredients needed.
Okay, thank you. So we always go back to the recipe whenever we make some changes on the quantity of ingredients of whatever we are cooking. Now, is this similar with chemical reactions? So let's look at the steps in solving stoichiometry problems to answer that question. So here are the steps in solving stoichiometry problems. So step 1 is to balance the chemical equation first. It is like establishing the correct amount of ingredients before cooking. Next one is to convert the mass of the given substance, that is mass A, to mole A. Okay, quick review. How many particles are there in 1 mole? Yes?
Ubaldo po.
Yes, Ubaldo?
6.02 times 10 raised to 23 po.
Okay, very good. So that's the Avogadro's number, 6.02 times 10 to the 23rd power number of particles. So for us to determine the number of particles for a given substance, we have to first identify the number of moles. Okay? So that's why we have to convert the mass of a given substance into moles so that we can have an idea how many particles are present for, let's say, for this mass of substance A or the given substance in the problem. Okay? So for step 3, we relate the moles of the given substance that we got from step 2, okay, with the moles of the substance with the unknown quantity. And we do that by getting the or using the molar ratio or the ratio of the coefficients based on the balanced chemical equation. So just like what we did in the previous activity, we refer to the recipe to determine the quantity of the other ingredients. Step 3 is similar to that. Now lastly is we convert the mole of substance B to mass of B. Now to better understand how these steps work, let's have a sample problem. So in this sample problem, we have here in the reaction magnesium plus HNO3 gives hydrogen gas plus magnesium nitrate. You were given 10 grams of magnesium, and we are asked here how much hydrogen nitrate are you going to use and how much hydrogen gas and magnesium nitrate will be formed. Okay, so the first step to solve this problem is, again, to balance first the chemical equation. Okay, so let's rewrite the chemical equation. We have magnesium plus HNO3. If this is dissolved in water, then this is nitric acid gives hydrogen gas plus magnesium nitrate. So let's balance first the chemical equation. So we have one magnesium atom on the reactant side and one magnesium atom on the product side. So it is balanced. Next element is hydrogen. We have one hydrogen atom on the reactant side and two hydrogen atoms on the product side. So this is not balanced. So what do we do to balance the equation? So we add a coefficient. And we add a coefficient 2 here on nitric acid. So we place here 2. So now we have 2 hydrogen atoms and 2 hydrogen atoms here on the product side. So it's now balanced. Now next, in this case, we have a polyatomic ion nitrate. Okay? Since on the product side, it's still nitrate, then we do not have to count the number of atoms one by one for the polyatomic ion. We just have to count the number of polyatomic ions itself. So for the reactant side, we have here this nitrate ion, and we have 2 nitrate ions. Then on the product side, we have 2 nitrate ions since we have the nitrate ion in the parenthesis and the subscript of 2. So therefore, we have here now a balanced chemical equation. So our balanced chemical equation is magnesium plus 2 moles of nitric acid gives 1 mole of hydrogen gas and 1 mole of magnesium nitrate. So that's step 1. Okay. Next step is to convert the mass of the given substance to mole. So what's the mass of the given substance? The mass of the given substance is 10 grams of magnesium. So let's write here 10 grams of magnesium. Now to convert mass of magnesium to mole, we have to multiply this with a conversion factor. And our conversion factor here will be the atomic mass of magnesium. So what is the atomic mass of magnesium? Anyone from the class? Yes?
24.31, sir.
By the way, who's this?
Alingod, sir.
Okay, Halingod. Halingod, again, what is the atomic mass of magnesium?
24.31, sir.
Okay, so it's 24.31 and the unit is Alingod. What is the unit for the atomic mass of magnesium?
Grams per mole po.
Okay, very good. So it's grams per mole. So whenever we write the atomic mass of an element, actually, you can read this from the periodic table as this. It's written like this. But we can actually rewrite this as 24.31 grams of magnesium over 1 mole of magnesium. Or we can also rewrite this as, we can invert this since these quantities are the same. It's like saying that 24.31 grams of magnesium is equivalent to 1 mole of magnesium. They're just equivalent quantities. They just have different units. Okay? Pareho lang sila ng quantity pero magkaiba nga lang ng unit. So therefore, since they are similar quantities, then we can uh, reverse the fraction. So we can also rewrite this as 1 mole of magnesium over 24.31 grams of magnesium. Now, these are the conversion factors that we are going to place here, okay, to convert grams of magnesium to mole. Now, the question is, which one of these conversion factors should we use? Let's say A or B?
Sir Asistores po.
Yes, Asistores.
I think it's B po.
Why?
For us to cancel the grams
Okay,
of magnesium.
very good. So let's see if we can cancel out grams. So Asistores said we should use B. So let's write it down here. So we have 1 mole of magnesium on the numerator and 24.31 grams of magnesium on the denominator. So since we have magnesium on the numerator for the given and grams of magnesium on the denominator in the conversion factor, then we can cancel this out, leaving moles of magnesium behind. So 10 grams times 1 divided by 24.31, what is the answer?
0.41 mole of magnesium po.
Okay, so it's 0.41. Okay, let me write this neatly. 0.41 moles of magnesium. So that's it for step 2. Okay, now let's move on to step 3. For step 3, now we are going to relate the quantity of the given, of our given, with the substance with unknown quantity. So in the problem, let's go back to the problem. The problem is asking for the quantity of HNO3 or nitric acid. So how much nitric acid are we going to use? Okay, so therefore we are going to relate the quantity of magnesium with the quantity of nitric acid. We now have the quantity of magnesium, which is 0.41 moles. So how much moles of nitric acid are we going to need to completely react with 0.41 magnesium? So we do this by following step 3. For step 3, we convert mole of A to mole of B using the molar ratio. And again, what do you mean by molar ratio? This is the ratio of the coefficients between the two substances that we are relating in the equation. So we have magnesium and nitric acid. These are the substances that we are relating. Okay? So the coefficients are 1 for magnesium and 2 for nitric acid. So we can have the conversion factor of 1 mole of magnesium for every 2 moles of nitric acid, HNO3. Or we could also rewrite this as the inverse. So for every 2 moles of nitric acid, we have 1 mole of magnesium. So this is what we are going to use as conversion factor to convert the 0.41 moles of magnesium to moles of nitric acid. So which conversion factor are we going to use? A or B? Anyone from the class?
Sir, Embaltorio po.
Yes, Simboltorio.
I think it's B po.
B, why?
Because we need to cancel out the moles of magnesium.
Okay. So we need to cancel out moles of magnesium, and B here is or has mole of magnesium on the denominator. Okay. And because of that, mole of magnesium will be canceled. So very good. So let's put that in our conversion factor. We have 2 moles of nitric acid, HNO3, and then 1 mole of magnesium on the denominator. Okay? So most of magnesium gets cancelled, mole of magnesium gets cancelled. So let's try to solve this one. 0.41 times 2 moles divided by 1. So what is the answer?
0.82 moles of nitric acid.
Okay, very good. So it's 0.82 moles of nitric acid, HNO3. Okay? So if you have 1 mole of nitric acid, you will if we will look at the balanced chemical equation, it states here that if you have 1 mole of magnesium, you will be needing 2 moles of nitric acid. Likewise, if you have 0.41 moles of magnesium, you will also be needing 0.82 moles of nitric acid. Same ratio as that of the balanced chemical equation. Okay? Now, the problem is actually asking for the mass of the other substance, which is nitric acid. So let us convert mole of nitric acid into mass. Okay? So we can do that by following step 4. So in step 4, it states here that we have to convert mole of B, or the substance with a known quantity, to mass. Okay? So let us convert mole into mass. And to do that, we have to determine first the molar mass of nitric acid. Okay? Because the molar mass of nitric acid will be our conversion factor here. Okay? So let us determine the molar mass of nitric acid. We have the elements hydrogen, nitrogen, and oxygen. So what is the atomic mass of hydrogen, class?
Sir Bartolome po.
Yes, Bartolome?
It's 1.01 po.
Okay, very good. So we have 1 hydrogen atom in the formula times 1.01 grams per mole. Okay, how about nitrogen? We have 1 nitrogen atom here. What is the atomic mass of nitrogen?
Simboltorio po.
Yes, Simboltorio.
Nitrogen po is 14.01.
Okay, very good. 14.01 grams per mole. Okay, how about oxygen? We have 3 oxygen atoms here, by the way. Yes, Duarom?
16 po.
Okay,
Grams per mole.
Okay, very good. 16.00 grams per mole. Okay, so let's multiply these atomic masses with the number of atoms in the formula. So 1 times 1.01, we get 1.01 grams per mole. And then 1 times 14.01 grams per mole, we get 14.01 grams per mole. And then lastly, we have 3 times 16 is
48 po.
16, okay, 48.00 grams per mole. Okay, add them up, we get 2, 0, and then 13. So we have 63 grams per mole. So this is the molar mass of nitric acid. So we can rewrite this molar mass as 63.02 grams of nitric acid, HNO3, over 1 mole, just like what we did in the previous examples that we had. Or we can also rewrite this as The inverse of this, we have 1 mole of HNO3 over 63.02 grams of HNO3. So which one are we going to use? Conversion factor A or conversion factor B?
Conversion B po.
Yes, why?
Kasi po sir, kailangan pong ma-deduct po yung mole ng nitric acid.
Ma-deduct or ma-cancel. Okay, kasi mole to eh. Tapos mole yung nasa numerator natin. So we have to use the conversion factor B here. Okay, let's write that in the conversion factor. We have 63.02 grams of nitric acid, HNO3, over 1 mole of HNO3. So medyo kinulang na tayo ng space. Let's write it here. So 0.82, by the way, we cancel out moles of nitric acid and mole of nitric acid here, since nasa denominator ito. 0.82 times 63.02 divided by 1. So what is your answer?
52 grams of nitric acid.
Okay, so we have 52 grams of nitric acid. HNO3. Okay? So therefore, if we go back to the balanced chemical equation here, so if we have 10 grams of magnesium, then we will be needing 52 grams of nitric acid based on our calculation. If we are going to look at the mass of the reactants and the mass of the products, so 10 plus 52, we have 62. And then, if we add the mass of the products, we have 0.83 plus 61. So this is approximately 62 grams also. So they almost have the same mass. Nagkaroon na kasi tayo ng ilang mga rounding off. That's why we got these quantities, but we have approximately similar quantities or mass of reactants and products. Therefore, we are still following the law of conservation of mass. And again, the law of conservation of mass states that mass is neither created nor destroyed. So therefore, the mass of the reactant should be equal also with the mass of the product. So do you have any questions, class, with regards to problem solving involving stoichiometry?
None so far.
None po.
Okay, so none so far. You can get a screenshot of this problem solving that we did so that you can have a reference for your future problem solving activities. So let's now move on with our group activity for today. So for our group activity, you are going to solve stoichiometry problem in Jamboard. So here are the instructions for this group activity. First, you are going to leave this Gmeet. Okay? Magli-leave kayo. Then, you are going to join the Gmeet per group. I have already sent the Gmeet links per group in our group chat. And then you are going to answer the problem using Google Jamboard. I have already posted the problem that you're going to solve in Google Jamboard. And then after solving the problem, you get a screenshot of your work and save it in Paint. And then you leave that group Gmeet and then rejoin this class Gmeet again so that we can analyze your work or we can check your work. Is everything clear, class? Do you have any questions about our instructions for our group activity?
Nothing, sir. All good.
Okay.
So guys, start na tayo.
Okay, welcome back to our class G-Meet. So, for this part of our lesson, let us have our presentation for our group activity. Let's have uh, Team 2 to present their work. Who will present their output for Team 2?
Me, sir, I'll just represent the.
Okay, sige. Go ahead, Timothy. Okay, very good. So, congratulations, Team 2. Now, for the other teams, please submit the screenshot of your work in our GC. And then, after checking, I'll just give you my feedback on your work. Okay? So, since we do not have enough time to give you time to present all of your work, uh, those other teams will have to send their work in our GC. Then I'll just give you your give you my feedback about your output. Now, again, thank you very much, Team 2. Analyze and reflect on what you have learned today and try to answer this question. Think about your future profession. How do you think the concept of stoichiometry would apply to your chosen field? For example, if you want to become a doctor or a nurse or an engineer, okay, or whatever profession you want to have in the future, how do you think the concept of stoichiometry would apply to your chosen field? Anyone would
Aling,
like to
Alingod,
volunteer?
sir.
Okay, yes, Alingod.
Our family is a family of farmers, and I think in a agricultural country like the Philippines, Bachelor of Science in Agriculture would be a very useful. And personally, I wanted to become a agriculturist someday. Stoichiometry is very useful in agricultural aspect. I can teach our farmers in my province how to use the proper amount of fertilizers to reduce pests for food security, yield productions, and other agricultural and ecosystem services. Thank you po.
Okay, very good. So that's how you can also apply psychometry if you want to become an agriculturist someday. Or like for example, if you would want to formulate your own recipe of fertilizer for specific types of plants, you could also apply stoichiometry in that respective field. Now, any other answer?
Sir Duma po, sir.
Yes, Duma?
Sir, I want to become a civil engineer someday. I can use the concept of stoichiometry when I measure amount of chemicals that I will use for my project. Like for example, when make a concrete, the different ratios of cement, sand, and other ingredients for different applications. The idea of stoichiometry will also give me a clue how much materials to use for a small house or for a large building.
Okay, very good. So very well said. So thank you for your responses. Of understanding homework in our GC so that those who cannot access uh, those who cannot access classcraft can still work on your checking of understanding homework. So again, this will be our evaluation for today. So I'll just give you my feedback in classcraft about your checking of understanding homework to clarify if you still have some uh, misunderstandings about our lesson for today, just refer to my comments or feedback to your output. And then for your performance task for this week, so please see the process homework posted in Classcraft. So this performance task is about designing a PowerPoint slide with animations to show the step-by-step procedure on how to solve a stoichiometry problem. So it's almost the same with the Jamboard activity that we did, but this will be on a PowerPoint slide. You'll be using animations to show the step-by-step procedure on how to solve stoichiometry problem. Now, for this process homework or performance task, you will be following these rubrics so that you will have a guide on how to for your output for this week. So again, the rubrics are uh, we have organization, content, multimedia design, and language. So please be guided with our rubrics when designing your multimedia presentation. Okay, so that's it for today. So see you next meeting. Goodbye, class.
Thank you, sir.
Thank you, sir.
Bye, sir.
Okay,
Thank you, sir.
bye-bye. Thank
Thank you
you.
po.
After the online class, the students will then work on their checking of understanding homework, practice homework, and process homework and submit those in Classcraft either through mobile app or direct website. Then, another pre-learning homework will be sent to them in preparation for the next lesson. That's it for my demo teaching. I hope you learned something. Bye!